Assalamualaikum warahmatullahi wabarakatuh and very good morning. Today we want to presenting for our research is about exploring the intersection of serverless computing and edge platforms, which is about performance, architecture and future directions. We are from group 12. Next. This is our group members. First is Muhammad Ashraf bin Muhammad Isha. Second is Najwa Fakri bin Nordin. And third is me, is Khairi Albi bin Yusuf. Fourth is Muhammad Harith Shahmi bin Mazlan. And the last one is Muhammad Azman bin Bazli. Next. First is about introduction. Introduction about what is serverless computing. Serverless computing is about enables developers to focus on code but not server management. It also utilizes stateless event-driven function that execute and terminate based on triggers. History and evolution of serverless computing. Introduced in 2014 with AWS Lambda. Serverless computing grew in popularity due to resource elasticity, scalability, and cost efficiency. Next, it evolved from SaaS, PaaS, and IaaS models. AWS Lambda simplified infrastructure management, boosting innovation. Next. Edge computing synergy. Edge computing synergy benefit in low latency by processing data near source. Serverless use ephemeral containers for resource optimization. Second is about function as a service, which is FaaS. Scales function based on event or triggers, fine-grained compute models, minimal maintenance. Third is about utility computing. Improves deployment agility and cost effectiveness. Extend edge computing capabilities for IoT, which is Internet of Things. And the last one is about research focus. Research focus about serverless architecture implication and challenges. We have 4 layers: virtualization and encapsulation, optimizing serverless deployment. That's it. Also introduction about our research. Next, I will give to my team members to presenting the next research. Thank you.
Okay, thank you to the Khairi Albi. Okay, my name is Najwan. Okay, and I will talk about the background of the study. Okay, first, we have the detecting concerns, which is it has 2 points, which is the architectural difficulties and performance optimization. Then we have the edge computing significance, which is we'll talk about the latency, bandwidth cost, data privacy critical for improving the QoS. And then we also evaluating the open source serverless frameworks for the edge computing. And next, we talk about the evolution of serverless. And in this topic, we will learn about the shift from monolithic to microservices. And then the serverless platform abstract server maintenance for agility or the cost. Okay, and then we go to the objective. This is our objective and our main objective. First, serverless enables code focus over server maintenance via event-driven functions. Evolving from cloud models, it complement edge computing, which is it make the edge computing become more perfect. How it make it more perfect? By improving the agility and IoT through FaaS auto scaling. And our research explores architectural implications across layers, evaluating the open source frameworks, evaluating the overheads, evaluating the tooling and cloud native aspects. And our key focus areas are including the platform development, web assembly integration, real-world characterization, technological difficulties, and tracing serverless origins for comprehensive architectural understanding and optimization. So we will use this. We focus on the areas to achieve the comprehensive architecture by understanding and optimize it to its fullest. Okay, that's all from me, and I will pass this to my next member. That's all from me. Thank you.
Okay, thank you Najwan. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arishami. Now I will present about problem statements. First thing first, edge cloud integration. Hybrid edge cloud infrastructures face challenges like managing burst workloads, addressing edge computing limitations, and effective auto-scaling for optimal performance. There is a need for effective systems that assure low latency answers. Next, we move to architectural optimizations. Exploring open source serverless frameworks, optimizing function composition, addressing architectural challenge for efficiency. Balancing availability, satisfying SLAs, and overcoming economic barriers under a variety of pricing strategies. Last but not least, we move to emerging technologies and considerations. Web assembly for constrained environments, regulating resource, addressing security, skill, compatibility, and optimization challenge. Okay, next we move to methodology. First, robust evaluation framework. Robust evaluation framework rigorous testing of serverless frameworks on hybrid edge cloud environments. Evaluation of popular frameworks such as OpenFast, OpenWhisk, and Link OpenWhisk. Next, we move to collaborative industry academia approach. It was partnerships with experts for relevant findings and literature review. Collaborative with academic and practitioners is key to expert cooperation and literature review that ensure study findings are relevant and applicable. Lastly, it was a comprehensive architectural assessment. In-depth analysis of system implications, performance attributes, and architectural trade-off. A comprehensive review of 275 papers on serverless computing. The selection criteria include GitHub contributors and stars open source license, developer community support, and programming language support. Okay, that's all from me. Now we move to Muhammad Azman.
Thank you, Hari. My name is Muhammad Azman bin Bazli. Now I will continue to present about proposed framework. The first proposed framework is edge performance evaluation that focus on key metrics like latency, scalability, resource utilization in edge environments. The second is real-time application showcase that demonstrate serverless adaptability and scalability for data-driven real-time recommendation. The third is a framework capability comparison that analyzes prominent serverless frameworks, capabilities, and limitations in edge computer scenarios. The fourth is architectural profiling tooling, specialized to like FAS profiler, enable detailed performance analysis and optimization. The fourth is replicable study design that promote transparency and rigor through replicable design and classification structure. And the fifth is WebAssembly implementation that resolve source isolation and control concern optimization and edge deployment optimization. And the last proposed framework is 4-layer architecture that provide insight into visualization, encapsulation, orchestration, and coordination layers. Mixed method development approach, the interview, literature review, web survey for comprehensive adaptation and understanding. Adaptive programming models that showcase serverless versatility through adapt model like Zappa and Shalice. Now we continue about the result and discussion. The first is framework evaluation. The framework evaluation tests OpenFAS, OpenWIS, and Lean OpenWIS on hybrid edge closed cluster, identifying performance variance, scalability issue, and optimization concerns. The second result in discussion is performance insights. OpenWIS had lower latency under concurrency but suffer bottlenecks. WebAssembly show better consistent performance. And the last result is comparative analysis. There OpenWIS had lowest performance, Kubeless scale faster, and WebAssembly had superior consistent performance and execution times. That from all for me, and now we go to the Muhammad Ashraf. Okay, Muhammad Ashraf.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Isham, and I would like to present about the conclusions and recommendations. So the first thing is the key findings. Serverless frameworks have significant performance implications in edge environments. Architectural consideration and optimization strategies are crucial. And the recommendations is assessing frameworks like Kubeless, Apache OpenWIS, OpenFAS, and native for specific use cases. Focus on response time, throughput, and deployment ease. And for future research, exploring alternatives like WebAssembly for better efficiency, promoting industry collaborations to address technical challenges. Okay, so we prepared for a related study, and for the first study is with the title of Serverless Computing: Economic and Architectural Benefits and Challenges, which focus on economic advantages and architectural constraints of serverless computing. The second study is Edge Computing for IoT: Performance Analysis and Optimization Techniques, which focus on performance optimization in IoT applications using edge computing. And the third study is Open Source Serverless Frameworks: Performance and Scalability in Hybrid Environments, which focus on evaluation of open source frameworks in hybrid cloud edge environments. And the last study, which is study number 4, is WebAssembly and Containers: Implications of Serverless Computing, which focus on comparing WebAssembly with traditional container-based approaches. Okay. And for references, the key references, number 1 is Serverless Computing: Economic and Architectural Benefits and Challenges. And second key references is Edge Computing for IoT: Performance Analysis and Optimization Techniques. The third one is Open Source Serverless Frameworks: Performance and Scalability in Hybrid Environments. Fourth is WebAssembly and Containers: Implication for Serverless Computing. And we prepare additional references, which is Systematic Mapping Study of Serverless Computing and Fast Profiler, Tool for Profiling Fast Platforms. That's all from our group. Thank you very much. See you next time. Thank you.